Welcome back, everyone. This is the Delta Workbook, and it's Mr. Australia here. Today we're on Lesson 6, and we're calculating the effect of repeated percentage change. If you haven't done so already, just pause the video and have a go at the Do It Now questions. Okay, number 1, we've been asked to find 10% of £14. This links in very nicely with the other work we've been doing throughout this topic. And whenever you're finding percentages of amounts, it's useful to think about what the original is. That's 100%. The original in this question was £14, and we were asked to find 10% of it. How do you get from 100% to 10%? You divide by 10. So you'll need to do the same thing with your monetary amount and divide that by 10 as well. Now, 14 divided by 10 is 1.4. But if you put 1.4 as your final answer, you will not get full marks because 1.4 is not technically a correct monetary amount. 1.4 is £1.40. Okay, so your final answer must be £1.40, not £1.4. Next, we've been asked to factorise this expression, x squared plus 3x. Factorise means take out the highest common factor from all parts of the expression. Now, what have I got in all parts of the expression here? I've got an x, so I'm going to take x outside my bracket. That is the highest common factor of all parts of the expression. X multiplied by what gives me x squared? Well, x squared is the same as x multiplied by x. Therefore, we will need an x inside our bracket as well to get our x squared. Now, x multiplied by what, gives me 3x. Well, it's going to have to be positive 3. Yeah, positive 3 multiplied by x, positive 3x. Next, we've been asked to solve the equation. 10 plus 2 brackets. This is a long equation, so I'm just going to move over and give myself a bit more space. Okay, so I'm going to write that out. Here we had 10 plus 2 brackets 2x minus 1, close brackets, and that was all equal to 16. Okay, there's a lot going on here. We first need to simplify it by expanding out these brackets. So I haven't done anything with the 10, that will stay the same. Positive 2 times positive 2x is positive 4x. Positive 2 times negative 1 is negative 2. And that's all equal to 16. Okay, now I need to simplify my number terms. I'm not going to do anything with that 4x, that will stay the same. And if you've got positive 10 and negative 2, positive 10 and negative 2, simplifying that will leave you with positive 8. And that's equal to 16 still. Next, I want x's on one side of the equal sign and numbers on the other side. So I need to get rid of positive 8. How do I do that? I need to turn it into 0 by subtracting 8 from both sides. I now want to get from 4x's to 1x. How do I do that? By dividing by 4. So I need to keep my equation balanced and divide 8 by 4 as well. So your final answer there will be x equals 2. I'm just going to rub that out. Got a bit of space to write our answer. Okay, so that was question number 3. And the final answer is not just 2, the final answer is x equals 2. That is the solution to the equation. Okay, number 4, we need to express 30 as a product of its prime factors. Lots of words there. Let's break it down bit by bit. First of all, let's start at the end. What is a factor? A factor is a number that goes into another number. Factors of 30 are times tables that 30 is in. So you've got the 3 times table, you've got the 10 times table, you've got the 5s and the 6s. They are all factors of 30. We're interested in prime factors. So you need to be thinking about your prime numbers. The smallest prime number is 2, then 3, 5, 7, 11, and so on. Final thing we need to do is the product. In mathematics, product means multiply. Okay, so we're first going to start off by finding our prime factors or our factors. What's the smallest prime number I know? 2. Is 2 a factor of 30? Yes, it is. So I'll write that here. 2 multiplied by what gives me 30? another factor of 30, 15. Now, because 2 is a prime number and I cannot find any more factors of it that are prime numbers, I'm going to circle it because I found one of my prime factors. 15, however, we can find some more prime factors. Does 2 go into 15? No, it doesn't. So I try the next largest prime number, which is 3. Does 3 go into 15? Yes, it does. 3 multiplied by what gives me 15? Multiplied by 5. These are both prime numbers as well, so I need to circle them. So what I've done is I've found my prime factors. I now need a product of prime factors. So I just write out the original amount, 30, and that was equal to our prime factor at 2, multiplied, this is the product part, the multiply sign, multiplied by 3, multiplied by 5. Okay, so you've got your prime factors and you've expressed it as a product of its prime factors. You've multiplied. Again, if you want to check, just do the sum yourself. 2 times 3 times 5. 2 3s are 6 times 5 gets you back to 30. Okay, next we're finding the median. So we need to add all of these values together. 2, add 5, add 12, add 2, add 15, add 8. Add all of those together. We've got 7, 19, 21, 26, 36, and then add that, we've got 44. So here we've got 44, once we've added them all together. And for the median, you need to divide by the total number of values. We've got 1, 2, 3, 4, 5, 6. So we're dividing that by 6. Let's do the bus stop method, make sure we don't make any mistakes. And I know that it's not, 44 is not in the 6 times table, so we're going to get a decimal value. How many 6s can we fit into 4? None. So that doesn't help us. We need to join them up. We're now thinking, how many 6s can we fit into 44? Well, 6 multiplied by 7 gets us to 42, but we've got a remainder. From 42 to 44, we've got a remainder of 2. So 6 multiplied by what gets me close to 20? 6 multiplied by 3 gets me to 18. So I've got another remainder of 2. This is going to keep happening, so we've got a recurring decimal. The final answer there is 7.3 recurring, or 0.3 recurring is the same as a third, so you could have 7 and 1/3. It hasn't specified what form it wants your answer in. Okay, so either one of those would be acceptable for that question. Next, we've got -3 plus 4 times 2. And here we need to think about our order of operations. Okay, the order of operations, the word you use is BIDMAS or BODMAS. Okay, and you're going down this way. Have we got any brackets? No. Do we have any indices or orders? No. Any division? No. The first thing we've got is multiplication. So we need to do that first. I haven't done anything with this -3. We've now got +4 multiplied by +2. That will give us +8. Okay, now I'm ready to do the final step. -3 add 8 gives you +5, which is just the number 5 on its own there. Okay. So using BIDMAS or BODMAS to help you with the order of operations, your final answer there is going to be 5. Okay then. So let's have a look at some of these examples. The first new language that we will have come across earlier in the year is interest. Okay. There are 2 types of interests we're going to learn about this year. We've got compound interest and simple interest. Simple interest we do not need to do in this activity, but I'm just going to show you a quick example just to show you the difference between the 2 of them. Let's have a think. I'll do simple, we'll do that in blue, and I'll do my compound in red. I'm just going to make up a question here just to try and show you the difference between the 2 of these. So let's imagine that we invested, let's say, £200 at 10% for 2 years. So with simple interest, what you do is you take that percentage. You would find 10% of 200. So 10% of £200. To find 10%, we need to divide that by 10. So that is equal to £20. Because we've got 2 years, we're just going to multiply that amount of interest by 2. So we do £20 times 2, giving us £40. And then we need to remember to add that back onto the original amount, which was 200. So 2 years, simple interest at 10%, you'd end up with £240. Another method, and this is the method we're going to focus on today, is compound interest. It's another type of interest that you could get. Now, with compound interest, what we do is we find the interest on the new amount each time. In the simple interest, we found the interest of the initial amount and just multiplied it by how many years. Whereas with compound interest, you would need to, again, if it's 10%, you would need to find 10% of the new original amount each time. Let's have a think about year 1. So year 1 would be very, very similar. We'd still find 10% of 200 equals £20. But then we'd need to find, for our second year, we need to find 10% of this new amount, £220. We'd add the interest to the original, okay? And 10% of £220 is going to be 22. We then need to add that on. So 220 add 222, sorry, 220 add 22 will give us 242. So as you can see here, the different type of interest will give you a different type of final result. Today, we're only going to be looking at compound interest, and I've showed you a non-calculator method here in red. Okay, that's something very similar to what they're showing you in example 1. An alternative method is when you're allowed to use a calculator and you have very large values that you're trying to find the interest of. Okay, so I'm going to leave this here actually, and I'll show you the calculator method in green. So this is the calculator. And we're going to use all the work that we've done in our previous units to help us out here, particularly converting from percentages to decimals. Here, if we're increasing by 10%, okay, 10% for 2 years. So I'll just do that. So 10% for 2 years. That's what we're doing now in green. We've done it here in red. I'm just going to show you the calculator method for how to do that now. So if we're going 10% for 2 years and it's increasing, we're going to always start with our original amount, 100%, and we're going to be increasing it by 10%. Okay? So it's like we're finding 110%. That's all one there, 110%. And to find 110% of something, you think back to our decimal multipliers. To go from a percentage to a decimal, you divide by 100. So to find 110% of something, you're multiplying by 1.10, or just 1.1. What we need to do now, though, is account for the number of years. And the way we can do that is by using our indices. Okay, using our indices. The amount of times you're going to have that interest, it could be years. Sometimes it could be months in a question. It could be weeks, or it could even, in a sense, be people. It's how many times you are finding that interest. Here we've got 2 years. That means I take my original amount, multiply it by 1.1, but 1.1 to the power of 2, because it was for 2 years. If I was doing it for, I don't know, let's say 3 years, that would be to the power of 3, or cubed. 10 years, I'd find my decimal multiplier and take it to the power of 10. Okay? However many times you are expected to find that interest, that will be your power. Okay? So the method we're going to be looking at today is this calculated compound interest. First thing to do is we found out how much percent we're going to have. If you're increasing, you will add the percentage. If you're decreasing, you will subtract the percentage. Then you go from your percentage to its decimal multiplier. Here we had 110%, so the multiplier was 1.1. Then you need to have a look back at the question and think how many years or how many weeks have they asked you to apply this interest for. In ours, it was 2, so we take our multiplier to whatever power that was. Okay. Finally, if it's any monetary amounts, you will have to make sure that you round it to a correct monetary amount. You'll see what I mean a bit further down. Let's have a go at some of the questions now. Okay. I'm going to start off doing these down here. Yes, I think that'll be clearer. Right. Okay then. So Josephine invests £3,500 in a bank account that pays annual compound interest of 4.5%. Annual means per year. So this is 4.5% every single year. In part A, we've been asked for 2 years. Right, we've got 4.5% and it's interest in a bank account. That means our money is going to be going up. So if we've started with 100%, and we've got 4.5% interest, then that means we're trying to find 104.5% of the amount. Okay, that's your step 1. What percentage are you trying to find? Then you want to convert that into its decimal multiplier. From a percentage to a decimal, you divide by 100. Okay, so that placeholder, you jump 2 spaces. So we're dividing by 100. And your decimal multiplier now is going to be 1.045. Finally, we need to think about how many years it is. Okay, I'll show you 1A here. So this is question 1A. Once we've done all of that hard work, we start with the amount. It's going to be 3,500. We found our decimal multiplier, which was 1.045, and we're doing it for 2 years. That means we will take our decimal multiplier to the power of 2. Just going to write out what part B would be now, just so you can see the difference. Again, you start with your original amount, £3,500. You multiply by your decimal multiplier, this question. But this time, it's for 3 years, so we'd be taking it to a power of 3. You're now ready to get your calculators out, so you want to do 3,500 multiplied by 1.045, and then you need to take it to the power of 2 or press the squared button. Some of you on your calculators, you might see the x with a small 2 above it, x squared, or you might see x with a filled in white box above it. That's going to be the most useful one for this activity because we're going to have lots of different powers, not just squared. So if you press that little box and then to the power of 2, press your SD button and you will get this value. Let's have a look. Remember, this is monetary amounts, okay? So we've got 3,822.087 ... Now, the reason why I've stopped my value there is because this is a monetary amount. Monetary amounts, they can only have 2 decimal places. Okay, so therefore we only need to write down the 3rd decimal place to tell us whether we're going to round that 2nd decimal place up or whether it's going to stay the same. This 7 is a 5 and above, which means we'll give the 8 a shove. So our final answer there, once we've rounded it, is going to be 3,822.09 or £3,822.09. Okay. Very similar thing here. What you want to do is you want to keep all of this in your calculator and you're just going to change that squared or to the power of 2 from a 2 to a 3 because you're now cubing it or taking it to the power of 3. Put it in your calculator and you will get, oh, just bear with me a moment. Okay, put it in your calculator and you will get this value, 3,994.081, and it doesn't even matter what the other digits are okay, because it's a monetary amount, we must be rounding to 2 decimal places. So your final answer there is going to be £3,994, and that will stay the same, so it'll be and 8 pence. Okay, so that was question number 1, and we're going to use a very, very similar method for the other questions. Okay, I'm just going to rub this out now. Okay, while we're doing that, let's have a think about question 2. So this time, Alan has bought a television for £320. It depreciates. So if something is depreciating, in general, words that start with a D, they generally mean going down, devaluate, decrease, depreciate. So that means this time it's going down by 15% each year. So the first thing I'm going to do here, actually, is work out what my decimal multiplier would be. We always start with the original amount, 100%, but if it's depreciating, we're taking away 15%. So what we've got here is we've got 85%. That's what we're trying to find each time. So our decimal multiplier that we're going to use is 0.85. Okay, just remember, percentage to decimal, you're dividing by 100. Right then, we want to know the value after 2 years. So let's set that up. We're going to start with our original amount. Actually, I'll do this one in blue again. Just for 2 years. So we've got 300, I'll put my units in, £320. Our multiplier is 0.85. And part A, we wanted it for 2 years. So we're going to take that to the power of 2. Ready to use your calculators now. We've got 320 multiplied by 0.85 to the power of 2. Press the SD button. And what you'll get is 231.2. If you leave your answer like this, though, you haven't given a proper monetary amount. 231.2 in pounds is £231, 21 pence. Okay, so that was A. Think about B now. It's going to be a very similar layout. We start with the original. It's still 15% depreciation, so we're still going to have the same decimal multiplier, 0.85. The thing that's going to change here is the number of years. We've got 3 years, so we're going to take it to the power of 3. Again, you keep all of the calculations on your calculator. You just need to change it from 0.85 squared to 0.85 cubed to the power of 3. Put that in your calculator. And what we're going to get out is £196.52. It goes in exactly there, so we can leave it as it is. So that was question 2A, £231.20, 2B, £196.52. Okay, question 3. This time we've got house prices. Now, percentages, this is something that comes into play a lot when you've got houses. As some of you might know, lots of people, when they're buying houses, they need to apply for a mortgage, which is a loan, and they will need to pay this loan back. But they will need to pay a percentage interest on the loan, because the banks, they don't just give you money for free. They actually charge you for borrowing the money, and they will charge you at an interest rate. Another issue with houses, where you might need to bring some maths in, is the rate at which they depreciate. Okay, they go down, or the rate at which they appreciate, they increase. Here though, this person, their house has depreciated by 2% per annum. Okay, so that's 2% per annual year, per year. Right then, so our original, if we're going down from 2%, our original will start at 100% as always. Going down by 2%, that means we're taking it away. So what we're trying to find is 98% of an amount. To find 98% of something, you can use its decimal multiplier, which is 0.98, just divided by 100. Okay, So this is question 3. This time it was for 6 years though. So let's start with our original amount. We've got £650,000. Our decimal multiplier that we worked out in the top right hand corner was 0.8. But this time it's 6 years. So we will need to apply that 6 times. We're going to take it to the power of 6. Type all of that into your calculator, 650,000 multiplied by 0.98. Then you press that X with the little box above it. In the little box goes 6, so it's 0.98 to the power of 6. What you're going to get out, you will get 575,797 pounds. These are our pence now. So 50, 4, 7. We don't need to write anything else because it's a monetary amount, so we must round to 2 decimal places. Final answer then, once we've rounded it, we've got 575,000, 797 pounds. It's 5 and above, give it a shove. That means that 7 will give the 4 a shove, and it'll move it up to a 5. However, if we have a look at this part of the question, we haven't just been asked to round it to a monetary amount, we've been asked to round it to the nearest 100. So we think about it, I've got my units here, my tens here, my hundreds are here. So actually, I'm going to need to round this down here. So my final answer is going to be 575,000. Okay, right, 5 and above. That 9 will give the 7 a shove up to an 8. Okay, so the final answer there is going to be 575,800 pounds. Okay, finally, question number 4. So Mr. Butterworth is on a diet and losing rate at 2% every week. So it's changed here. This time it's every week rather than annually or every year, but it's still the same process. Okay, we're still going to need to apply that 2% decrease every single week. And we're doing that for 8 weeks. Okay, first things first, let's think about our percentage and then our decimal multipliers. So if you're losing weight, you're depreciating, it's going down. That means it's going down by 2%. So we would find 98%. Similarly, as in our last one, 98% is 0.98 as a decimal. Okay, and we've started with 110 kilograms. We found our decimal multiplier, it's going to be 0.98. But this time, it's gone for 8 weeks, and we're losing this every single week. Okay, we're losing 98% of our body weight every single week. So we need to do this 8 times. So we're going to take it to the power of 8. Okay, get that in your calculator and then turn multiply by 0.98. Then it's the X button with this blank square above, and you put a small 8 in that square. Okay, what we've now got is 93.5839. Now, in the question, they haven't told us what to round it to. So that means you need to decide yourself, but you must label with whatever you have rounded it to. I'm going to choose 1 decimal place here. So that means I'd look at the number after that, the value after that in the second decimal place, an 8. 5 and above, we give it a shove. So the 8 will round the 5 up to a 6. We had our units, we were weighed in kilograms, so we need to put those in our final answer as well. So your final answer there is going to be 93.6 kilograms. That's if you've rounded it to 1 decimal place. Any of you that rounded it to 2 decimal places, go down here instead, and it'd be 0.58. But you must make sure that you label how many decimal places you've done it for, if they haven't asked for it in the question. Okay, and that is the end of lesson 6. Today we were calculating repeated change. And next you're going to have a think about your assessment. Okay? The assessment's included in your workbook. And what we'd like you to do is do some revision, have a look through the workbook, and then complete that assessment in test conditions. Okay. Something else that's going to help you in your revision is going to be your Hegarty maths clips. Here they are clips 91, 92 and 94. They will have tasks to go along with them. And then you've also got the Corbett link, which would be task 236, your textbook exercises with the apply section, and also your practice questions, your GCSE style questions. Okay, thanks again everyone, and I'll see you again in another workbook.